Right, hi and welcome back to our educators. So video yang ni pula saya nak teruskan dengan what I tinggalkan dengan you pada video part 6, which is to compare the reactivity. Okay, so now you nak compare reactivity. Okay, kat sini saya tak suruh you compare reactivity which one. Okay, if let's say you nak compare reactivity antara natrium, kalium, natrium dengan lithium pun boleh juga. To compare of any two pun boleh juga. Okay, saya bagi secara basic lah kan. Okay, we all know that the first sentence should be the atomic size. Betul? Okay, fine. Dah kata atomic size. Okay, it's okay lah. I just give the question. Okay, let's say the question is, okay, this one is the question. Okay, ni soalan dia. Compare the reactivity of any two elements in group 1 when going down the group. Okay, let's say lah, I choose, okay, wait lah, take this color. Okay, I choose sodium and also potassium. Okay, tak apalah, you choose this one, right? Okay, so you kena lukis lah, saya tak perlulah, saya just boleh copy paste je. Okay, right. Okay. Sorry, in my place is currently it's like tengah hujan, so you boleh dengar bunyi-bunyi hujan pun. Okay, so you kena compare the reactivity of sodium and also potassium. Okay, remember that your first sentence is compare the atomic size, betul? So you kena bagi tahu how does the atomic size lah works. Okay, so the atomic size, okay, this one involves your observation skill. Okay, so the atomic size of which one is bigger? The atomic size of potassium is bigger than, or you can say is larger lah. Okay, is bigger than sodium. Okay, so you dah compare the atomic size. Okay, enough. Then your next sentence is compare atomic radius. Okay, when you nak compare atomic radius, dia ada satu package tau. You kena compare with the number of shells filled with electrons. So the number of shells filled with electron for which one higher ataupun banyak, for potassium ke sodium? See the diagram, potassium. So the number of electrons, the number of shells filled with electrons for potassium is greater lah sebab banyak kan, greater than sodium. Thus, okay, atomic radius yang mana besar? Okay, ingat, if you want to see the atomic radius, right, okay, we measure atomic radius from the nucleus to the valence shell. Cuba tengok. Okay, this is the atomic radius for potassium, and for this filler from this nucleus to this valence shell. Cuba tengok atomic radius which filler is panjang, which is larger. So sodium punya ke potassium punya? Mestilah potassium punya. Thus, wait lah, alright. Thus the atomic radius of potassium you want to say bigger pun boleh, larger pun boleh lah. So I want to say the atomic radius of potassium is larger or bigger lah. It is bigger than sodium. Okay, so this is how your second sentence looks like. First, you bagi tahu atomic size. It's a must tau. You kena start dengan atomic size dulu. Once you dah talk about atomic size, then you talk about which element have the more number of shells filled with electrons. So by buka your mata, you can see potassium punya number of shells is more than sodium. So you should say that one. Number of shells filled with electrons greater for potassium than sodium. Thus, atomic radius of potassium is bigger than sodium. This is your ayat. Okay, then next you should talk about the position of valence electron. Okay, so you can say like this: the valence electrons in the valence shell for which one? For potassium lah. For potassium is further away. Okay, memanglah dia jauh kan, is further away or further apart lah. Okay, buku teks guna further apart, is further apart from the nucleus compared to what? Compared to sodium. Cuba tengok valence electron, which one is far? Potassium punya ke atau sodium punya? Of course lah potassium punya. So you should say the valence electron in the valence shell for the potassium is further apart from the nucleus compared to sodium. Okay, wait, ayat ni lengkap tak? I want to check. Oh, tambah sikit. Okay, because you know that the interaction is between electrons and proton, right? So kat sini boleh tambah the valence electron in the valence shell for potassium is further apart from the proton. Yeah, proton in, okay wait, I ubah sikit, in the nucleus compared to sodium. In the nucleus compared to sodium. Okay, so this is how your sentence looks like. So baca lagi sekali. The valence electron in the valence shell for potassium is further apart from the proton in the nucleus compared to, sekejap, I bagi lengkap, compare to the valence electron in the valence shell. Terus yang sama juga. Give your sentence which is like betul-betul tak bagi pemeriksa question you. Okay, but there is one mistake actually. Wait, I show you the mistake. Compare to the valence electron in the sodium. In the valence shell. Wait, in the valence shell for sodium, which quite near lah, dia quite near, betul. So you just can say compare the valence electron and the valence shell for sodium. Cukup lah sampai sini pun. Okay, but one thing is, remember wherever we talk about electrons, we should talk about the atoms, betul tak? So the second one is the number of shells filled with electron for potassium atom, okay, is greater than sodium atom. Dia kena macam tu. I memang forget just now. Okay, for potassium atom is greater than sodium atom. Okay, wait. Greater than, clumsy-nya. And sodium atom. Okay, sodium atom. Thus, the atomic radius for potassium is bigger than sodium. Okay, the valence electron in the valence shell for potassium is further apart from the proton in the nucleus. For potassium is further apart from the proton in the nucleus compared to the valence electron in the valence shell for sodium atom. The word atom is essential actually. Sodium atom. So kat sini pun you kena tambah sodium atom, potassium atom. So wait a minute. So this is your third sentence. Wah, pening dengan third sentence ni. So it's simply you kena bagi tahu that you punya kedudukan valence electron, the position of your valence electron in the valence shell for your potassium is far away from the protons in the nucleus. Okay, you kena bagi tahu macam tu, but you should compare. So the best way to compare is you should say the valence electron in the valence shell for potassium atom, the valence electron in the valence shell for potassium atom is further apart from the proton in the nucleus compared to the valence electron in the valence shell for sodium. Okay, this is how your sentence looks like. And your final sentence, sentence terakhir you. Okay, wait, this one I nak kemaskan sikit. Oops. Tak apalah, nantilah yang ni. Okay, so your fourth sentence lah, bukan final sentence. Once you talk already about the valence electron and the what do you call that? And the position of nucleus to valence shell, then only you talk about the nuclear attraction force. So for the nuclear attraction force, you should know the nuclear attraction force is between the protons in the nucleus and electrons in the valence shell, right? So you should say like this: the nuclear attraction force, okay, attraction force for for potassium, sorry, tak payah banyaknya, sekejap saja. The nuclear attraction force between protons in the nucleus, ataupun proton pun enough lah. Okay, here I write protons lah. Protons in the nucleus and electrons, and valence electron lah better juga. Okay, and valence electron in the valence shell. Okay, jangan kata valence shells, valence shell ada satu saja. Okay, valence shell. Okay, for which one stronger? Okay, so you dah kata dah potassium punya size bigger, so dia ada banyak electron. And then this point, the third point, you say the valence electron in the valence shell for potassium atom is further apart from the proton in the nucleus of potassium atom. Betul? So the nuclear attraction force for potassium you rasa weaker ke stronger? Okay, so yeah, right, for potassium atom is weaker. Dia weak lah. Okay, is weaker compared to what? Compared to sodium atom. Okay, sebab sodium atom kan atomic size dia kecil. So the nuclear attraction untuk sodium atom lah strong. Betul. So now dah talk about nuclear attraction force, then only talk about the electron. So in this case, group 1 should donate the electron. So which one is easier to donate its electron? Which one can donate its electron easier? So the potassium atom can donate its valence electron easily. Okay. Okay, don't say electrons, valence, okay lah, valence, boleh je valence electrons, but actually it's not electrons sebab dia ada satu valence electron saja, so no need to plural it lah. Okay, in grammar pun kena berhati-hati juga. Potassium atom can donate its valence electron easily compared to sodium atom. Sebab nuclear attraction force for which one stronger? Remember that if your nuclear attraction force ni stronger, kiranya hard to donate electron for group 1. You dah kata dah atomic size potassium is bigger than sodium. Betul, you dah kata dah. So when the atomic size is bigger, atomic radius for potassium is bigger than sodium juga, tu pun betul. Okay, after that then you talk about the valence electron. So you can see the valence electrons located in the valence shell. So the valence electron in the valence shell for potassium is further apart from the protons in the nucleus compared to the sodium. Okay, sodium. That's how I answer you. Memang I know the third sentence a bit confusing lah. Okay, kenapa? Sebab you have to explain betul-betul detail. Memang ramai sangkut kat this third sentence because they feel like, hey, macam mana cikgu ni jawab kan? Because the reason why I put valence shell because of the valence electron. Valence electron only located in valence shell. So I say the valence electron for potassium which was in the valence shell is further apart from the protons because the interactions is between electrons and electrons in the valence shell and also protons in the nucleus. That is why I make emphasize with this word. Okay, proton in the nucleus. So you can see the valence electron is far for potassium lah. okay, from the protons in the nucleus. So you should mention like this. Third sentence ni memang you kena berhati-hati lah. Kalau you faham konsep ni slow by slow, you boleh tahu. And then the nuclear attraction force. So nuclear attraction force between what? Between protons in the nucleus and valence electron in the valence shell. In the valence shell for potassium atom is weaker compared to sodium atom. Thus, potassium atom can donate its valence electron easily compared to sodium atom. So this is your full marks. Okay, macam mana dapat your full marks? Okay, dari segi your buku teks, they explain first atomic size. Dia bagi tahu yang mana size dia besar. Then second, dia bagi tahu valence electron in the valence shell and protons in nucleus are further apart. Which one lah further apart? Then dia bagi tahu force of attraction, nuclear attraction. I lupa the word force. Oh my god. Okay, add force nanti. Ni saya dah correct dah. So nuclear attraction force. So bagi tahu lah nuclear attraction force for which one strong. You buka mata. Ini mestilah strong sebab kecil. Ni big, so mestilah weak. Betul tak? Then for sure the potassium atom can donate its valence electron easily compared to sodium atom. So now my question is, compare the reactivity. So which one is more reactive? Potassium or sodium? So which one easy to deliver its electron? Potassium, right? So potassium more reactive than sodium. Tu je. Okay, this is the final answer. Sebab I ask compare the reactivity. So you should compare the reactivity macam ni lah. Bagi tahu atomic size, then bagi tahu number of shells, then bagi tahu valence electron which one is further apart. So from the valence electron baru boleh tahu nuclear attraction force. From that baru you tahu which one can donate its valence electron easily. Then final sentence baru you bagi tahu potassium more reactive than sodium. So this is your full marks. Okay, so this is a type of example question lah that they may ask, and this may jadi soalan bahagian B, you who knows kan. Okay, so please copy the answer betul-betul and pay attention to this point nombor 3 ini. Okay, to the third point ni. Okay, kena jawab betul-betul. Okay, this third point is very crucial point. Okay, wait I put okay, so itu sahaja I rasa for this part. Okay, I have another one thing to cover, which is properties of rubidium, cesium and francium. Betul tak nama dia saya pronounce? Wait I see the textbook. Yeah, rubidium, cesium and francium. Okay, ada student dia kata kat saya, kami nak tahu kenapa kita tak belajar pasal rubidium, francium semua kan. Okay, wait I give the reasons here. Okay, you know all group 1s are alkaline metals. All are metals. Okay, but why we didn't learn this particular metals punya apa nak kata reaction? Okay, because for the reaction we learn for lithium, lithium, sodium and potassium saja kan. Okay, kenapa we didn't learn? This is the reason. Okay, do remember that. Okay, you remember, you kena remember lah. Okay, can ask in paper 1 lah. Okay, if people ask you for properties, okay, name the properties of of rubidium. Rubidium is Rb, cesium is Cs and francium is Fr. So remember that properties, you have two type of properties, which is physical properties and also chemical properties. Betul tak? Okay, so if physical properties, okay, you know those group 1s are metals. Okay, so physical properties for this fellas, that what you can see, okay, all those are soft metals. Okay, already stated out in the buku text also, they are soft metals. They have shiny surface. Okay, memang tahu group 1 elements everyone have the shiny surface. All the metals are shiny surface and they have low melting and boiling point. Okay, they have low melting and boiling point. So I can write here lah, low melting and boiling point. So these are literally tu katanya you should remember, low melting point and boiling point. Okay, this one you should remember, no choice at all. Okay, Lepas you dah kata about these physical properties, okay, then you should know about the chemical properties as well. Okay, I write in a different color lah. Okay, chemical properties. Rubidium usually combine with other elements, thus they're very difficult to isolate it chemically. Okay, chemical properties, we have to understand like this. Okay, alright, kat sini lah. Okay, chemical properties. Okay, usually chemical properties is akan ditentukan based on reaction, betul? Okay, remember that your rubidium ke, francium ke, ataupun cesium ke, Sc, okay, they are very reactive towards water and oxygen. Okay, very reactive. That's why kita tak test tiga-tiga benda ini dengan oxygen dan juga water. Okay, because dia boleh cause a strong explosion, might be. Okay, so that is why kita tak belajar pasal dia punya application in water. Kalau you ingat, kita belajar application for water for sodium, lithium and potassium sahaja. Okay, and next thing is your francium. Okay, francium ni, kejap saya tulis. Okay, francium, this fella ni kat sini ada, they are unstable radioactive isotope with a short life. Okay, so that is the reason. Ni saya dah tulis dah. Okay, so rubidium, francium and cesium secara naturally they are very reactive towards oxygen and water. And francium ini, this fella, dia unique sikit. Dia is a radioactive substance. So you kan tahu kan, radioactive isotope atau radioactive substance, dia cepat decay. So dia tak stable. By the time saya ambil nak check pun dia dah decay dah. So boleh ke tahu chemical property? Tak boleh lah. Okay, and then rubidium and cesium itself pun dia orang kawan baik. Okay, dia orang are very reactive. We know potassium pun very reactive. Betul yang we test with water, oxygen all kan, dia burns, dia explode kuatly kan. But rubidium and cesium lagi kuat, very very reactive, and they can combine with other elements easily. So when they combine, susah lah nak isolate dia, betul tak? So that is why we don't learn any application for this fellas. Okay, and another one thing lah that you all should know. Okay, I already told in the video dari awal sampai lah akhir to the final part now about alkali metals, right? But do you ever wonder how in the lab, your teachers, your lab assistants keep your alkali metals? Have you ever wondered how are alkali metals stored or kept lah? Okay, kept in laboratory. Okay, laboratory. Okay, and then why? Okay, how does they keep it in laboratory and why? Okay, remember that dah nama pun alkaline metals, they can react with oxygen very reactively. So we will keep it in the what? In the paraffin oil. Remember ke paraffin oil that we learned in chapter 1? All of these alkaline metals, AlKaline, alkaline metals were kept in a reagent bottle containing what? Containing paraffin oil. This one saya rasa pernah expose on exam. Saya pun tak berapa ingat, but I just want to let you all know lah, sebab dia boleh combine cross chapters. Okay, paraffin oil. Okay, why they keep in paraffin oil? Because they want to avoid having contact with water vapor, wap air. Okay, with water vapor and oxygen. Okay, because you know our air, I mean our udara memang ada oxygen and they are water vapor, wap air. So when these alkaline metals react dengan your water vapor or alkaline metals, when react with your water vapor or oxygen, diorang can cause strong explosion. So which can cause strong explosion. Boleh meletup lah. So nanti you perlu duduk kat kubur lah. Okay, tu pun bukan you punya rangka sahaja. So that is why these alkaline metals we store in the laboratory in a paraffin oil. Okay, kita akan letak in a bottle macam ni lah. Okay, this may be the bottle. This is test tube. Okay, maybe this is the bottle. This is the bottle kan. Okay, so this is the reagent bottle. So half kita ada paraffin oil. Tak percaya tanya lab assistant. Puan tolong tunjukkan kat saya macam mana puan simpan logam alkali. Dia akan tunjuk lah kat you, especially the sodium oil, everything, mostly the metal tau. The metal will be in the paraffin oil. And yang ni semua rubidium, cesium, kalau ada lah in your school lab, like very rare to get. Kalau ada, ask them where you store it. They will show to you how they store it. Okay, so itu sahaja my notes for today. Such a long notes saya rasa for this particular subtopic sahaja. So I will meet you in next subtopic with 4.7. Okay, but one thing, do remember that you should write these notes and scan this QR code. Okay, this is one. So for anyone want my handwritten notes yang ni, you can see in the TikTok channel lah. I will post there. Dari sana you take and you use lah for your personal purposes. Okay, so itu sahaja. Let's say bye bye.